We're going to go through a problem and see how the formula for the sum of an arithmetic series is derived. So the problem is that we have a theater with 50 rows of seats, which has 18 seats in the first row, 20 seats in the second, 22 in the third, and so on. So the number of seats is going up by 2 each time. We're going to find how many seats there will be in the last row, and we're going to find how many seats there are total in the theater. Now what we have is an arithmetic sequence if we think about each row of seats, because it's going up by 2 each time, so we have a common difference of 2. We know that we can use this formula to find the nth term of an arithmetic sequence. Using the numbers we have, we need the first term and the common difference. The first term is 18, and we have a common difference of 2, so we can set up the formula to calculate the number of seats in row n. Now we're specifically looking for the number of seats in the last row, so we're going to plug 50 in for n and calculate, and the last row contains 116 seats. Now we're going to use this information to help us find how many seats there will be total in the theater. We're finding the sum of an arithmetic series. Often we use S for a sum, where we use A for the term in a sequence. So S sub 50 would denote the sum of the first 50 terms of our series. Now, we could just straightforward add up all these numbers, but we would have 50 numbers to add up, and what if we had 100 rows or 1,000 rows? It would take a very long time. So there's a nice thing we can do with arithmetic series. What I'm going to do is regroup the numbers. So I take the first with the last, the second with the second to last, third with the third to last, and so on. So what I'm doing is pairing up each of those numbers to get the sum of the first 50. Here's what's nice about this. 18 plus 116 is 134. 20 plus 114 is 134. 22 plus 112 is 134, and so on. So what we would get is 134 repeatedly added. Well, we can do repeated addition with multiplication. We just need to know how many 134s there are. Now remember, our series has 50 numbers in it. Well, when we split those up into pairs, we get 25 pairs. So to finish off this problem, we have 25 times 134, because we'd have 134 for each pair and 25 pairs, giving us a total of 3,350 seats in the theater. What we want to do now is generalize this so we can do it for any arithmetic series. Let's think about where the 134 came from. It came from taking the first number plus the last number. Now where did the 25 come from? It came from the number of terms in the series divided by 2. So using that information, we can generalize to get our formula to find the sum of any finite arithmetic series. It's the number of terms over 2 times the quantity of the first term plus the last term.